Go back and I turn on the caliper. I can move that as close as I can to the center, or just move it to an edge. All you want to do is make sure you can duplicate it. Then I'll hit my second caliper. I'll move that down, say at least 3 centimeters. I'll move it to the bottom there again. Get it right below. Hit set. Where's my measurement? Oh, here we go. 2.98 centimeters. We're expecting 3 centimeters. That's very good measurement. So that's showing that our axial measurements are right on. I'll then move over and we'll get a measurement where we have like this one right here where it's measuring crosswise. Freeze. And again, because the resolution in that direction is not as good, what you'll find is that it's harder to make the measurement. What you'll end up doing is making an educated guess that it's center to center. And it's measuring 2.03, and that's a 2 centimeter distance up here to 4.5, and so again, that's very accurate. You could do the math on the percentage, but it's a very good measurement, and it shows it's not off, and that's critical, and you want to document that. The other thing that you're documenting besides the axial and lateral resolution, the axial and lateral measurement, is you're looking for uniformity of the image. That's another thing a Phantom is good at showing you. That's a nice uniform image. If it got darker down here, then brighter here, and that would show you that you either needed to adjust your settings for your TGC controls, for example, or that you had a problem with the focusing on the system itself. If you looked in the near field and you had dark dropout, that would be indicating you've got an issue with the transducer and likely dead crystals. You could easily put another transducer on, the same type of probe, same imaging setup, scan the Phantom, and you'd readily be able to tell if that was your transducer that was at issue or not. Looking in the near field, I don't have that burned bright like you would on some probes, especially deeper probes. This high frequency probe has a nice clear near field on there. When you're doing something like looking for a breast cyst to find out if you're going to do a biopsy or not, that's what you want to be able to see, is a nice clear near field. Going back over to this side, this transducer is a higher frequency and we're not going to be able to get the depth that we probably want. What you'd like to be able to do is see a multitude of the rods running down the side and be able to see them go from lighter to darker all the way down. A higher frequency transducer will not go as deep in the body as a lower frequency transducer, and that's why we're not able to see these plexiglass rods down here very well. If I get off to the side, I can see them better, and with the linear transducer I would see them a little bit better as well. But move over here to the cyst. Now this is supposed to be duplicating a cyst, and if it's a true cyst, this is going to be very dark and black. It's not going to have a lot of noise in the middle of it. That's the type of thing you want to look for here. So this gives you a way of evaluating how much noise you have in the system, and if your cysts look like clear cysts or if they don't. And that's another thing you want to document with a photograph. If I go back over here to my frequency, and I was explaining that the transducer with a higher frequency will penetrate less in the body. That's another typical function you might want to measure. So you look at a Phantom and you find out the last part where you can actually see the image before it just starts to turn to noise and you can't really see any detail. If I go and I change the frequency of the probe to a higher frequency, I went from a 5 to an 8, and you can see how that dropped off, and my amount of penetration has dropped all the way down to there. That doesn't show a problem with the probe. It shows that we're using a higher frequency transducer. Again, you would document that so you can compare one probe of the same kind and be able to find out if it's performing the way that it should. Those are the most typical uses of an ultrasound Phantom, and an ultrasound 2D grayscale Phantom like this one, a tissue mimicking Phantom, is by far the most common. I told you there were other Phantoms, the ones I mentioned before, such as the breast, the prostate, and the head and neck. Those are just similar phantoms with a little different physical structure so that you can put a transducer that would be used for that. But they also have a fetus 3D transducer that looks literally like a fetus embedded in a block of gel like this. And what that's particularly good for is doing a 3D scan where you're doing reconstruction. You want to be able to see a face. That's very difficult to do, and you'd have to have a good phantom in order to pull off something like that. And you'd be able to see that that was 3D. What you'll notice is that we're not doing any color in this phantom. The one thing that a typical phantom like this does not do is it doesn't do Doppler, which would include color Doppler. And that's because that will only work with moving targets and something with roughly the same ultrasound characteristics as blood. And there are very expensive high-end phantoms rather to do that. One of them is called a string phantom, and it literally is a block of water. It has some material inside that is roughly the acoustic properties of blood, and it has a moving string that has small beads on it. And because of that, it can measure the motion, and it can actually verify that you've got the correct frequency scanning for your Doppler, and it will even do color and show that it's got the right frequency. Those are much more uncommon because they're very expensive, and they typically would just be in a good lab that had a reason to test that. Most of the Doppler verification is actually done electronically now, where it can inject a frequency and measure it back. So that's a use you're going to find of your transducer. It's much easier than scanning your body. Your body's a great phantom if you do yourself all of the time and you're very familiar with it, but this has the advantage of being able to document the exact same settings, exact same everything on each system you're looking at, and to be able to track it through time. Use your phantom well, it'll help you out, and it will very easily show you if you've got issues with the system or not. And that's it for a 2-minute tip today.